This conference will now be recorded.
There we go. Right, Sam, thank you very much. Over to your good self.
Thank you. Can you see my presentation?
Yep, we can see your presentation. Yep.
Okay, brilliant. Thank you. So, as Philip said, this is a presentation on the in-possession approvals of rail plants for use specifically on Network Rail, although other infrastructures do use similar processes. It's limited to the in-possession approvals because the outside possession approvals of plants is a whole nother presentation in itself. And it's mainly focused on the process. Obviously, as part of the technical review and approval of plants, there's a lot of engineering review that goes on. And I'm happy to take questions on that. But in terms of this presentation, it's largely focused on the process because the technical aspects of plant could cover a number of days. So, as Phil said, I'm Sam Barrett. I'm a senior plant engineer at AEGIS Certification Services. Prior to that, I worked at Atkins as a plant engineer, and prior to that at Network Rail as a plant and rolling stock engineer. So I've seen the plant approvals process both from the certification side and from Network Rail for process side. So I thought I'd start with really the scope of what I mean when I say rail plant, and broadly this falls into three categories. We've got on-track machines, on-track plant, and what is broadly categorized as portable and transportable plant. So on-track machines are the big machines that you see running around the network, essentially under their own power as trains. So these two examples here, you have a rail milling machine at the top and a tamping machine at the bottom. Both of them will leave a depot, travel under their own power along the network under proper train signal controls. And then they will arrive at a possession, deploy their work equipment, undertake some work, pack their work equipment away, and then leave the possession again as a train and drive back to the depot. So these really are railway specific pieces of kit. After that, you've got on-track plant, and this is rail-bound or rail-borne like the on-track machine. So it has rail wheels if they travel up and down track, but they are limited by their certification to only being used in a possession. So they will arrive on the back of a low loader, either be lifted off the low loader onto track, or in the case of road rail vehicles, they will drive a short distance on the road, drive up onto a level crossing or a road rail access point, deploy their road wheels, and then travel down the track. So they may travel some distance along the track, but that will only ever be within a possession. They'll then get to their place of work, carry out the work, and then pack themselves away and drive off. So this largely covers road rail vehicles. That's by numbers certainly the most common type of on-track plant. But it also covers demountable machines, which are possession-only machines that don't have rail vehicles. So you get things like small tamping machines or perhaps small grinding machines that will arrive by road and be lifted onto track and will then undertake their work within a possession and then be lifted off track again. It also includes wheeled attachments. So on the top right-hand side here, you have a ballast brush, which attaches to an excavator and so largely forms part of the excavator, but because it has its own wheels and has the potential to be left on track on its own rail wheels, it has its own approval and is a piece of on-track plant in its own right. It also includes another common thing that we see quite a lot of at the bottom here. You can see the road rail vehicle at the front, but it's towing a rake of rail trailers. These are another very common piece of on-track plant used for transporting often ballast, but anything down the track really. And again, like other pieces of on-track plant, they're limited to only being used in a possession. So unlike what we call a wagon, which is approved for running around the network, these are only approved for use in a possession. The final category, which is the broadest category really, is what's called portable and transportable plant. So this is all plant that doesn't have rail wheels. So the examples I've given here are a rail saw and a piece of stressing kit. Other similar examples are things like impact wrenches or sleeper drills, but it also includes non-rail borne larger plant. So for example, excavators that don't have rail wheels, or even cranes and things like that. It's essentially any plant that's used on the network rail infrastructure that doesn't have rail wheels. So what I mean by approvals really is the certificates that you need to use a piece of plant on network rail infrastructure. So we'll go through each of the processes involved in each of these certificates as part of this presentation, but to use a piece of plant on network rail infrastructure, you need those 3 certificates, and gaining each one is its own process and has its own technical requirements. So that's what I mean by the approvals of rail plant. If you buy a piece of rail plant, how do you go about getting the relevant certificates to then go and use that in a work site on network rail infrastructure? So why do we need plant approvals in the first place? There's certainly always a pushback on the amount of approvals involved in the railway. Approvals isn't limited to plant. Everything that's used on the railway, from the track, signal, train, all goes through an approvals process. And there can be a perception that plant is lower risk than, say, a signalling system. And from one point of view, it is really. It doesn't interact with passengers in the same way that, say, a train does or a signalling system does. But plant is one of the largest workforce safety risks. So when we're thinking about risks to essentially our colleagues, other railway workers, plant, along with electricity and contact with trains, is one of the biggest risks on the railway itself. I think driving to site is probably the biggest risk, but once you're there, plant is one of the things that has the potential to cause the most serious accidents, and can also impart some lower severity but higher occurrence risks, so things like vibration and noise and manual handling, which can all lead to negative health impacts for the workforce. So in terms of some specific examples, the last multi-fatality workforce incidents that I know of on network rails infrastructure was the Tebay Runaway. And this is actually 20 minutes down the road from me, so it's local to me, and it's often thought of as one of the worst plant accidents on network rails infrastructure. This trailer that you can see here was loaded up with many tons of rail. It had gone through the correct approvals. It had brakes fitted, as was newly required at the time, but someone modified that brake system, essentially disabled it. The trailer became disconnected from the machine that was towing it and ran away and struck 4 workers and killed them all. So that was an example of a piece of plant that had the necessary approvals. Someone modified it, didn't seek to gain the necessary approval of that modification, essentially because they wouldn't have got it, and the plant went on to kill 4 people. 10 years later, this is a sleeper spacer, which is you attach it to the end of a crane or to the end of an excavator, use it to lift concrete sleepers on. It was a 4-sleeper grab. It had the correct approvals as a 4-sleeper grab. Someone modified it to be a 5-sleeper grab. It failed, and it dropped a concrete sleeper on someone's leg, and they eventually lost that leg. So again, this was a modification to an approved piece of plant that wasn't scrutinized, wasn't certified, and went on to cause a life-changing injury. In 2015, and this is actually one of the first plant projects I worked on was the investigation following this incident. This is 11 years after the Tebay trailer runaway. These two Ironmen, which are used to lift and then transport lengths of rail, ran away from here for 5.5 miles through 3 level crossings and a work site. Now, the people pushing it actually jumped onto the Ironmen and then shouted warnings to the work site as they approached, and everyone jumped clear. But 11 years after the Tebay incident, this was almost another multi-fatality incident from rail trailers running away. Now, in this case, the trailers actually had all of the necessary approvals, but I think in retrospect, it's thought that perhaps the approvals process wasn't quite as robust for that type of manually propelled equipment. It sort of fell into a grey area. It was rail-borne, but it didn't go through the same approval process as other types of rail-borne plant. It perhaps didn't get the amount of scrutiny that, say, a trailer that was propelled by a machine would get. And since then, these sorts of manually propelled trailer have been added to the standard for other types of trailer, and the approvals process is significantly more onerous for them. And this is one from, I put last year, that's when I wrote this presentation. It may actually be 2 years ago now. But this is a machine that I actually did the approvals for. I got sent this photo on a Sunday afternoon, and I could tell from the asset number on the front, it's one that I had recommended for certification. Clearly, it's become unstable and overturned. Now, actually, in this case, the safety system had been disabled. So the machine had all the necessary approvals. We went back and checked the review that was done. The review had been done correctly, but then on site in the efforts to complete a job, the stability monitoring system was turned off and that machine turned over. But that really highlighted to me the need to get the certification right and to ensure that what we do is robust, because had I got something wrong, I would forever have to live with that machine going over. Thankfully, the person in the cab came away completely unscathed, which is quite remarkable, really, when you look at what's happened to the cab. So the whole approvals process for plant is really derived from legislation and the legislative need to manage safety. So when you look at approvals processes and trying to understand them, I think it's important to understand the legislation that they're derived from and the legislation that they are trying to enforce and achieve compliance with. So when we look at the railway, as I'm sure everyone's aware, the railway has its own suite of legislation that is rail-specific legislation. The almost unique thing about plant or working a possession in general is that from a legislative point of view, a possession is not the railway anymore. The PICOP or the engineering supervisor has taken control of that piece of railway away from the signaller. The signaller has set protective signals at either end and then handed control of that piece of track to essentially local control. So at that point, from a legislative point of view, the possession stops being railway. So if it's not a railway, what it is really is a construction site, and the legislation that applies in that possession is the sort of legislation that applies in construction site or a factory or any other place of work where machinery is being used. So on the railway, we have the sort of legislation that railway engineers are generally familiar with. There's the Railway Interoperability Regulations, which are essentially the technical compliance legislation, the Common Safety Method, which mandates a common method for undertaking and undertaking risk assessments and managing risk. And ROGs, which are the sort of operational side of the legislation. None of that applies really inside a possession, and inside a possession we have the sort of legislation that you'd hear about generally relating to the workplace. So the Health and Safety at Work Act, the provision and use of work equipment regulations, and the supply of machinery regulations. So all of these pieces of legislation apply in a possession, also apply in a factory, also apply in a construction site. So a lot of the certification processes are derived more from what we broadly call civils engineering than from railway engineering. Yeah, so out on the railway section of this, the approvals processes dictated by legislation. Within a possession, it's dictated by legislation, and it's also mandated by Network Rail through their contracts. So Network Rail, in conjunction with the rest of the industry, have produced processes that, if followed, will ensure compliance with the relevant legislation. So in terms of the actual approval types outside of a possession, you have notified body approval, designated body approval, assessment body review, compatibility assessment, and then finally ORR, authorization into service. And this is, broadly speaking, the approvals process for any railway subsystem. So it could be a new signalling system, a train, a bridge, any structural subsystem of the railway. Inside a possession, these are the three processes that we'll cover in this presentation. You have self-certification for the Machinery Directive, engineering acceptance, and then Network Rail's product acceptance process. On other infrastructures, you have a similar final step of product acceptance. So there's a London Underground product acceptance process, for example. So how these so this is the scope of this presentation, really, this inside a possession section. The railway specific approvals outside of a possession are another very complex presentation in themselves. So how this actually applies to something like an on-track machine, which is both a train and a machine. It runs around in traffic as a train. So the legislation that applies are the interoperability regulations, the common safety method, ROGs, and you have approvals processes like NOBO-DEBO approval, ASBO, and your ORR, authorization in service. The on-track machine then arrives at the limit of a possession, and it stops being a train, and it starts being a machine. So legislation that starts to apply is things like the Machinery Directive, the provision and use of work equipment regulations, and the Health and Safety at Work Act. And the approvals are, as we discussed before, self-certification, engineering acceptance, and product acceptance. So for something like this, the piece of on-track plant, it is clearly to look at, not a train. It's only ever used in a possession, and it's only ever a machine. So the approvals that apply are your possession-only approvals, so self-certification, engineering acceptance, and product acceptance. For your non-rail-borne plant, the main difference from on-track plant is that there's no engineering acceptance. We'll go into the detail of it later, but really engineering acceptance is a compliance review against your rail-specific standards. Now, the non-rail-borne plant doesn't need to run on rails, so it doesn't need those sorts of rail-specific standards, and it's so varied that you couldn't have a single standard to cover all of those types of plants. So that's limited to your self-certification, and then the product acceptance process. So it's more they review by the infrastructure manager and an engineering acceptance review. So the approvals process itself is written down in this standard, which it's RIS 1710. It is a rail industry standard, so a lot of infrastructure managers have input to it, and RSSB ultimately own the standard and publish the standard. But it is heavily influenced by Network Rail, and I think I'm right in saying that Network Rail would be, of all the infrastructure managers, the one that stick most rigidly to this process. London Underground do actually have their own process which follows this, but they have their own approvals process that's been in place for some time. So the process itself is made up of the 3 parts that I discussed earlier, and that starts with self-certification to the Machinery Directive. So the Machinery Directive is a piece of legislation, and the manufacturer essentially declares on a piece of paper that their machine complies with the Machinery Directive. And they do that for each machine. So if they build 10 machines, they'll do that 10 times. The second step is the engineering acceptance to agreed industry standards. So this is done by a plant assessment body, who AEGIS certification services are one of them. Essentially, it's done by a third party. It's not done by the manufacturer. And again, that's done on every machine. So every machine will have its own individual certificate. The final step is product acceptance to the infrastructure manager's requirements. So whereas engineering acceptance is sort of broad categorization of railway risks and how to manage them, the final step is the infrastructure manager's chance to mandate their specific requirements. So it might be specific risks on their infrastructure, but it's also specific compatibility issues on their infrastructure. That's done for Network Rail product acceptance. It's done by Network Rail, although more recently they have delegated some of that responsibility to the plant assessment body. So a plant assessment body can undertake the review and then make a recommendation to Network Rail, and Network Rail will issue a certificate. And this is done on the first of class machine only. So this is done on each type of machine. So if you produce 10 machines of a single type, they'll have one certificate that will cover that type of machine. Obviously, if you make a change to the machine during the production run, then you'd seek a second product acceptance certificate for that. So starting with self-certification to the Machinery Directive, that's the Machinery Directive. It's a piece of EU legislation that essentially says what machines must be like. It applies to all machines. So from a blender to a lawnmower up to a high output ballast cleaning machine. So to achieve that, it is necessarily broad in its language, and it doesn't seek to be specific about what specific machine types should look like. So as part of EU law, and after January the 1st, it will still be part of UK law, a manufacturer of any machine has to self-certify that their machine complies with the Machinery Directive. There's 2 parts to that. There's a CE mark that they put on the machine itself, and then there's an EU Declaration of Conformity. This is the certificate that they draw up, and someone holding a suitable technical position in the company will sign that certificate. So from January 2021 onwards, the process will be almost exactly the same as far as I know, except instead of a CE mark, We'll have a UK CA mark, and instead of an EU declaration of conformity, we'll have a UK declaration of conformity. In terms of the actual technical requirements for the machines, they will be identical as of January 2021. Obviously, as time goes on, then there will be the possibility that technical requirements could start to deviate from EU requirements. But for the moment, the technical requirements for machines will essentially stay unchanged. So on that EU Declaration of Conformity, the manufacturer lists all of the applicable legislation that their product complies with. So you can see here, the Machinery Directive is listed there as the first one. Another one that you often see is Electromagnetic Compatibility Directive. Obviously, most machines have some sort of EMC immunity and emissions requirements. So as I said before, the piece of legislation that is the Machinery Directive is necessarily broad in its language. The problem with that is that it doesn't make it a particularly useful thing to follow if you're trying to design a machine. If you have a specific road rail vehicle that you want to build, going to the Machinery Directive wouldn't give you much detailed guidance on how to make your machine safe. So to assist with this, we have harmonized standards. So these are standards for specific pieces of equipment that give detailed requirements for that piece of equipment, and the EU publish in their journal saying that if you comply with the relevant harmonized standards for your piece of equipment, you can, by a presumption of conformity, say that your equipment complies with the Machinery Directive. So if you were designing a lawnmower, rather than trying to work out from the Machinery Directive what it should look like, you could go straight to the lawnmower standard, read through it, will tell you all of the safety systems you need on a lawnmower, build it to that standard, and you can then say that you comply with the Machinery Directive. So it essentially does a lot of the work for you in terms of determining what safety systems you need for your specific product. Luckily, we have harmonized standards for all the various types of plant that we use on the railway. So there are a lot of railway specific ones, so road rail vehicles, on-track machines, trailers, manually propelled machines, and your demountable machines. For the non-rail-borne plant, so something like an impact wrench or a sleeper drill, there would be non-railway specific harmonized standards. So there are harmonized standards for petrol-driven impact wrenches, for example. So if anyone's interested, I think this presentation will be sent out afterwards. If you need the harmonized standard for your specific piece of equipment, then follow this link and it will list the many hundreds of harmonized standards for the Machinery Directive. So when we go back to our EU Declaration of Conformity, if as a manufacturer, we have designed our machine to the harmonized standards rather than directly to the Machinery Directive, we can list that on the EU Declaration of Conformity. So you can see that this one is for the product is a widget manufacturing machine, and they stated on the Declaration of Conformity that conformity is shown by compliance with the applicable requirements of the following documents, and these documents are harmonized standards. So this first one is a general risk assessment standard, and this second one, EN 746, would be a design standard specific to their widget manufacturing machine. So that informs the purchaser of the equipment that not only does it comply with the Machinery Directive, but you have used a industry recognized standard in determining your compliance with the Machinery Directive. So that's a self-certification, the first step in the whole process, and it's done by the manufacturer at the manufacturer level. The second step is the engineering acceptance to the agreed industry standards. So it's assessment by a third party of a machine's compliance with agreed industry standards. So if that's your machine, that's your agreed industry standard, and then a third party is someone like AEGIS certification services or another company that has been accredited to carry out this engineering acceptance review. So our sole purpose as an entity is to carry out third-party certification of machines. By only undertaking certification, we ensure that we remain as a third party at all times. We're not involved in the design and manufacture of the machines themselves. So the standards themselves, there's only two of them. They are, again, they're rail industry standards. So they're not British standards, they're not Euro norms, they're drafted by a panel hosted by the RSSB. On that panel, there'll be Network Rail, London Underground, other infrastructure managers, I believe, if they wanted to join, a manufacturer's representative and an RSSB representative, and they collectively decide what the industry wants in terms of technical requirements for machines. So when it comes to that engineering acceptance process, we undertake a slightly different process for what we call a first-of-class machine and a second-of-class machine. So if you think about a production run of machines, the first one that you produce will be your first of class. You may then produce 1, 10, or 100 identical machines that you're going to declare the design is the same as the first one. It's important to fully understand the definition of first of class because it's more onerous on the railway than other industries, and the second of class machines really do have to be exactly the same design as the first of class. So something having the same model number doesn't necessarily mean it's the same. Or you could buy 2 VW Golfs that were completely different. So when we talk about a first of class machine and a second of class machine, the second of class really is identical to the first in its design, its production, and its testing. Variants within a product type ultimately will lead to a new first of class. So the first thing we do on a first of class review is a clause by clause analysis. So we take that industry standard, we tabulate it, and the applicant, so generally that's the manufacturer, although it may be the purchaser, states for every clause in the standard whether it complies with the clause or not, how it complies, so they'll give some short compliance statement, and then the supporting evidence. So that supporting evidence will be a design, perhaps an operator's manual, some sort of stress analysis, but essentially that's where the detail of the compliance sits, is in that supporting evidence. This checklist brings together all that evidence and shows how compliance with the standard is achieved. Once we've done that clause by clause review, we do a site visit and we go and see the machine. We inspect it, we undertake a number of tests on the machine, and we confirm both that the machine complies with the standard itself, but also that the machine complies with the design. So what has been stated in the checklist and what has been provided as evidence is an accurate representation of what has actually been built and what is going to go out onto the railway. So we'll do things like wheel load measurements, delta Q over Q testing, brake testing, stability testing. Depending on the machine, we'll do a number of different tests, but essentially it's confirming the performance of the as-built machine rather than the designed machine. For a first-of-class machine, we'll also do a maintenance review. So there are a number of requirements in the standard for what the maintenance must cover. So it says specifically that maintenance must cover rail wheel profile checks, for example, but also in general, we need to confirm that the machine is going to continue to comply with the standard after it's been certified for its life. There's no point building a machine that complies with a standard the day it leaves the manufacturer's premises and then degrades to a state where it no longer complies. So that's where the assessment maintenance review comes in. It's ensuring that maintenance tasks and the pass-fail values set at maintenance have enough factors of safety built into it that as the machine degrades, it never degrades below the level defined by the standard. So the standard is the required performance level of the machine for its entire service life, not just on the day the certificate was issued. So for a second-class machine, we undertake essentially a comparison to the first-class machine and then just a desktop review of selected pieces of evidence. I've copied here our second-class machine checklist, and this is the entirety of it. It's 2 pages. Now for a first-class machine, that clause-by-clause analysis is thousands and thousands of lines. For a second-class machine, we're looking at 10 to 20 lines. So that's where that distinction between a first-class review and a second-class review is really important. The second-class review is undertaken on the basis that it has been designed identically to the first one. If it's not been designed and built identically to the first one, we need to go back to the standard and redo that clause-by-clause analysis to ensure that the machine still complies. But typically on a second-class machine, we can confirm that the wheel loads of the machine were within 5% of the first-class machine. The software functionality was the same as the first-class machine. The correct decals have been fitted, the machine's been painted correctly. Functional checks of the machine have been carried out. If it's a lifting machine, then some stability testing has been carried out, although that would be limited compared to a first-class machine. But it's really a confirmation that A, it's the same as the first-class machine, and B, the things like decals and paintwork are correct and have been applied. So something that comes up quite a lot as part of our review is where a machine doesn't comply to the standard. So I've zoomed in here on the clause-by-clause checklist that we use. And these are in the compliance level column, these are the 5 levels that an applicant can declare. So either the machine complies with the clause, or there's no change from its previous approval. So where the machine was already certified and say you're undertaking an engineering change, perhaps the change doesn't affect that clause, in which case you could just say there's no change in previous approval. You could say that the clause isn't applicable, which will be the case for many clauses. You could say that it doesn't comply with the clause. Obviously, that will lead to you not getting a certificate. And the only final option is a derogation. So where the machine doesn't comply with the clause, but you have a valid reason for it, and that's often the case, a derogation needs to be sought from Network Rail. So in not infrequent cases, there's a very valid reason for a machine to not comply with the standard. The standard will be trying to mitigate a risk in a certain way, and the manufacturer will have chosen a different, perhaps more suitable way to mitigate that risk, which doesn't necessarily comply with the standard. And from an engineering point of view, that's a logical and acceptable way to manage risk, and Network Rail recognize that. the issue is that as a certification body, we don't have the authority to make that decision as to what's reasonable or not. So where a manufacturer could spend time trying to persuade AEGIS certification or the other plant assessment body that what they've designed is reasonable, really what they need to do is go to the person that enforces the standards, which is Network Rail, and ask for a derogation from them. Once Network Rail issue a derogation, we can just accept that certificate and close the clause. So the final step in what we do in the engineering acceptance is a signatory review and then certification of the machine. So the assessor will have spent somewhere between, say, 20 and 30 hours reviewing a machine. A signatory who signs the certificate may spend 3 or 4 hours. They are deliberately separate from the assessment process. They're deliberately removed from that process to try and give another layer of impartiality to it. And they check, A, that the assessor was competent to carry out the review, B, that the process has been followed correctly, and C, they will do some spot checking of technical evidence to essentially dig into what they consider to be the higher risk areas of that machine. If they're happy with what's been done, then they'll sign a certificate, and that certificate will give safety relevant data for the machine, so weights, brake pressures, things like that, and then a number of limitations. And those limitations are the way you must use the machine to ensure that you comply with the standards. So a copy of that certificate is held on the machine, and those limitations essentially give you the way that you are permitted to use that machine on the Network Rail infrastructure. So in terms of the process requirements for the certification review itself, we are, as a plant assessment body, accredited by UCAS to undertake certification activity. They accredit us in accordance with this standard, which is an international standard on how to undertake conformity assessment and certification. So it's not railway specific. It could be certification of rail plant, but it could also be certification of pressure vessels or a management scheme or anything else you would like to certify. So this is the process that we follow in terms of how we're going to certify a machine. We also follow a similar standard on how we're going to inspect machines, again, to that conformity. And then the standard that is formed the same series as these two, but sits on the applicant's side of the process, is how to test a machine. So how do you ensure that the testing that you undertake is impartial and repeatable and accurate? So these three standards really dictate how the process of conformity assessment should be undertaken. In terms of what they actually say, the testing one, a common thing we see is test results just given as pure results. If you look at this, this is the wheel load test report. If you were to look at that, it would tell you what the wheel loads were, but it wouldn't give you much information about the actual test process and the results themselves. So that standard tells you the minimum things you need to include on a test report, and it's relatively minor. You can see this is all still fits on a single page, but we now have a lot more information about what's going on here. So there's methodology and the pass-fail criteria. So we can at least see that the pass-fail criteria was set before the machine was tested. You've got some machine information, so specifically a unique identifier for that machine. Importantly, you've got your calibrated tool information, so where you're using load cells or something like that, you need to ensure that they're in calibration. you got your test result, so whether it passed or it failed, and you've got authorization by someone who hasn't carried out testing. So someone has undertaken the testing and someone else has reviewed it to confirm that the results are correct. The other really important process requirement that I touched on briefly earlier is impartiality. So if you think of essentially two sides to the manufacture and certification of a machine, on one side you have the design, production, maintenance, ownership, testing, specifically to us, authoring compliance statements. On the other side, you have the review and the certification. Now, the people undertaking the review and the certification can't have been involved in any of this. The whole concept of third-party certification is that you're not reviewing your own work. So if I were to work as a manufacturer and design a machine, if I then moved to AEGIS certification and wanted to certify that machine, I wouldn't be allowed to. I could certify other machines, but not one where I had input to the design. Ultimately, it's trying to prevent you from feeling the need to certify something because you were involved in the production of it. That could obviously either be for monetary gain, you want to sell the machine, but it can also just be that if you made a decision in a previous role to then say that decision was wrong, it would put pressure on yourself, and ultimately it'd be a conflict of interest. So the people undertaking the review and the certification on a machine, that is the only activity they will ever undertake on that machine. And it's why AEGIS is actually two separate companies. So we have AEGIS Certification Services, who I work for, and all we do is review and certification of machines. And we have AEGIS Engineering Systems, who are a traditional engineering consultancy. They undertake design, advice, they might offer a maintenance plan, but they work on essentially the production side of the railway. And any certification body has to exist in its entirety as a certification body alone. So if you look at other large railway consultancies, they will often have a consultancy company and then a smaller certification company, which, although it may use the same branding and be owned by the same group, it is its own separate entity with its own profit and loss account. So the final stage is the Network Rail product acceptance. As I mentioned earlier, traditionally, this is always undertaken by Network Rail, and for other product types, so for, say, track or signalling or electrification, it's still undertaken by Network Rail. For plant, because there is such a wide variety of plant, they get a lot of applications, and Network Rail simply can't deal with the volume of product acceptance applications they get for plant. So about 2 years ago, a scheme was set up where the plant assessment bodies would undertake step 2, as they always have, and would then also undertake a large part of the review for the product acceptance. So although Network Rail retain authority for issuing the certificates, we will undertake a review and make a recommendation to them, and they will largely act on a recommendation that we make. In terms of the process itself, it starts with the applicant tells Network Rail about what the machine is. Network Rail review that, and they define a scope of review and the depth of scrutiny that they would like the plant assessment body to undertake. Either us or an engineer in Network Rail will then scrutinise the plant against those predefined requirements, and will make a recommendation to the Network Rail head of plant, who will, if he agrees with the recommendation, sign a certificate. So the first step in that process is the assessment level application. So the applicant will use this form from Network Rail to essentially describe what the machine is, how it works, what its intended use is, and then using this risk matrix, assign a perceived level of risk to the machine. That takes into account both safety risk, but also performance risk. So if that machine fails to function as intended, what are the performance implications to the network? From that, Network Rail will assign an assessment level. That varies from assessment level A, where they need to do a full common safety method assessment, and as a reviewer, we need to review essentially every line of everything in detail. So every line of a hazard record, every line of any standards compliance assessment, things like that. As you go down the assessment levels, the depth of scrutiny starts to reduce slightly. So we might start picking certain lines of a hazard record to review. As you get to assessment level F, that is an extremely minor change that essentially involves a check that the applicant has declared they comply with legislation. So generally, the sort of a new product will be from assessment level C upwards. Changes might be assessment level E. It's extremely rare to have an assessment level F. That is really a very low level of scrutiny. The other thing that Network Rail might do at the assessment level application stage is to say that they want some sort of formal investigation taking into account. So where they know they've had an incident with a similar piece of plant, they'll provide us with an investigation report and ask us to consider the outputs of that report in our review. So the actual scrutiny itself, it's much like the engineering acceptance really. Network Rail have a 26-clause checklist, and we go down line by line and ensure that the machine complies with each of those clauses. The difference from the engineering acceptance is that where the rail industry standards are very specific technical requirements, the product acceptance requirements are broader and less technically specific. So they, as you can see from here, they largely relate to the hazard record and the risk assessment process. So there is a lot of review of how the manufacturer has undertaken their risk assessment, identified the hazards posed by the machine, and how they are proposing to manage those risks. There's also a fairly high focus on competency management and user manuals, but that really links back into your hazard record and risk assessment, because out of your risk assessment will be defined your operational risk controls and the competency of the people operating those machines and how they will enact those risk controls. Another notable one here is product performance. So essentially, the machine must do what it says on the tin. Network Rail wants the machine that's brought into possession to undertake a task to be able to effectively deliver that task. So if you say that your tamper can tamp 2 miles in a shift, then you need to demonstrate that, because at the planning stage, someone from Network Rail will plan in works on the assumption that a tamper can tamp 2 miles a shift. If it can't, then that will have a negative impact on the network. So we discussed self-certification at the very start of this process, and I mentioned that it was undertaken by the manufacturer, and well, it is, as I said, it's a self-certification. Generally there's no third-party scrutiny of it, and if you built a non-railway machine and sold it into the market, the only time your self-certification would be scrutinized would be if something went wrong, if it ended up in court. However, Network Rail's product acceptance requirements say that we need to confirm the presence of supporting documentation and review of the logic behind that declaration. So this is recognizing that in a self-certification process, there is the possibility that someone can just stick a CE mark on it and write a certificate without actually putting any logical thought into what they're doing. So as part of product acceptance, we will ask them to demonstrate that they have followed some sort of logical process in determining compliance with the Machinery Directive. We discussed Harmonised Standards earlier. Often what we find, and in an ideal situation what we find, is that the manufacturer has taken a Harmonised Standard and produced some sort of clause-by-clause compliance justification against that standard. We wouldn't look to review that in detail like we would at engineering acceptance, but we would check that a suitable technical file exists and that the manufacturer understands what they're doing by placing the CE mark on the machine. The final thing we do as part of product acceptance is we complete what Network Rail call the principal questions, and these are questions that they ask of us as the reviewer to provide them with a summary of what we think the manufacturer has done. And really, although there's a number of questions, they all largely relate to the hierarchy of risk control. So how has the manufacturer sought to control risks? And ultimately, what we want to see is that risks are either eliminated by design, they are substituted by design for some lower severity hazards, or that people have been isolated from the hazard. As you come down this hierarchy, you start moving into what's called here administrative controls, but they can be thought of as operational controls, and it's essentially relying on someone to do something to ensure that a hazard doesn't occur. And obviously that's something that we want to avoid as much as possible. We want our risk controls to be at the top of this pyramid, so designing out the risk or designing some barrier to the risk. Those principal questions and Network Rail asking us how the manufacturer has ensured that wherever possible, their risk controls are at the top of this hierarchy. The way that this product acceptance process can deviate somewhat is for a higher complexity product, or a product that has the potential to interact with a number of disciplines on the network. So an example would be a new type of tamping machine that tamped in a different way to previous versions, has the potential to affect the track in quite a fundamental way. So whereas for most pieces of plant, the Network Rail head of plant sets the requirements, for something that's going to fundamentally affect track, the head of track will also have something to say about it. So where we have our 26 plant clauses and they make up the requirements for the machine, if a system review panel is called by Network Rail, the other technical disciplines will be allowed to add requirements to the product acceptance process. So that can be the track, signaling, EMC, ergonomics, any technical discipline in Network Rail can set additional requirements. The really important thing to do here is to see the system review panel as early as possible and get those requirements defined and documented, because ultimately they will affect the design of the machine. So that definition of requirements needs to happen as early as possible, and the system review panel needs to be engaged as early as possible. Generally, this is limited to on-track machines. So machines that can drive around the network outside of a possession, they are largely the only pieces of equipment that could fundamentally alter the way the railway system works outside of a possession. So the final step, as I said before, is a recommendation for certification, which we make the Network Rail. We draft a certificate on a Network Rail template. We give that to the Network Rail head of plant, and they sign the certificate and send it out to the manufacturer. And this is the final piece of paper you need to then start using your plant on the Network Rail infrastructure. So that's the process really. In summary, you've got the 3 steps: the self-certification, which is done in-house by the manufacturer; your engineering acceptance, which is the bulk of the technical compliance review; then the product acceptance to Network Rail's specific infrastructure requirements. And these are the certificates you end up with. So to then use your machine on the network, you'll need your EU Declaration of Conformity, an engineering conformance certificate, and a Network Rail product acceptance certificate. Once you've got those 3, the piece of plant is ready to be used in the infrastructure. And that's it. Thank you very much.
Thank you very much, Sam. That's really appreciated. Turn on my camera as well so you can see me. There we go. Right. Thank you very much. There's a few questions in the chat already. If anyone else has any questions that they want to add into the chat, please type them in now. I shall start asking questions if you're happy to carry on, Sam. So first one is from Jamie Walsh, and it's also related to another question that came later, which was from Steve Clark. For the instance for which you certified the machine, this was quite early on, so this is the RRV that fell over, if memory serves me right. Why is it so easy to override the safety controls? And then Steve Clark followed that up with, to add to Jamie's question, is consideration given to the ability to override safety controls when certifying machines, and how is that undertaken?
I agree. The override shouldn't be so available, in my opinion. Generally, safety systems are not so easily overridden, and when I discussed the hierarchy of risk controls, certainly having a design control that can so easily be operationally overridden would not be pushing yourself up towards that hierarchy of risk controls. The reason specifically on excavators that you can override the stability control is they have what's called a dig mode. So the vast majority of lifting that is done on Network Rail infrastructure is actually done with excavators, not with cranes. So stability control systems, which monitor the position of the machine and the load on the machine, are retrofitted to excavators. The problem is you can't dig with a load control system in, because the breakout force to rip the earth out of the ground will very temporarily be above the stability force of the machine. So these excavators have a dig mode, and the excavator can essentially be switched between a lifting mode where the stability is controlled and a digging mode where the stability isn't controlled. So the full override of the stability system is done with a key, which is in a locked compartment in the machine, and which will set off sirens around the machine. Unfortunately, largely due to the fact that we use excavators for lifting, you can actually just switch it to dig mode, and that stability system essentially is turned off. There is an external indication on the machine that you're in dig mode, but unfortunately, I think the use of dig mode when lifting is fairly prevalent. I wouldn't be surprised if, when a new issue of the standard comes out, which I think will be sometime next year, there will be some additional requirements in there about essentially engineering interlocks on dig mode. So some way of ensuring that you cannot enter dig mode unless you really are digging. But it's something that's been discussed and is recognised as a risk.
Cool, thank you very much. Next question then comes from Michael James. So from your perspective as an assessor, you check compliance to legislation, e.g. TSIs, international standards, ENs, railway standards, ROI group standards and RIS, and company standards, e.g. network rail standards. What is your view of the strengths and weaknesses of each type?
That's a good question. I think legislation, things like TSIs, are often well written but broad in their application. So necessarily by having to apply to railway systems across Europe, they have a lot of open points and things like that. Euro norms, I think, vary. They are, because they are specific to machine types, they are much more useful at the design stage. Railway group standards, well, railway group standards and rail industry standards. Well, if I start with rail industry standards, can use subjective language, which makes applying them difficult. So they might use words like sensible or suitable, which are entirely dependent on the person reading them. So I think that is the main weakness, certainly of the rail industry standards that I use. The good thing about rail industry standards is that they're drafted by the UK rail industry, and they're very good at managing UK specific risks and being written in a way that accounts for the way the railway operates in the UK, and to some extent the way products are manufactured in the UK. So I think in terms of technical requirements and the writing of technical requirements, Euro norms are probably the highest quality, and I'm sure that's essentially down to the fact that the review and publication process of a Euro norm is extremely onerous, and it can take years for a Euro norm to be published. But they can be, the requirements can not be suitable to UK railways. They are also sometimes, well, in fact, I would say all of the above, I would say, are too wordy from my point of view. I think in general, standards could be written in half as many words with the same number of requirements, and it would increase levels of compliance because they'd be better understood. But I think that applies to all of the above, really.
Okay, thank you. I'm going to follow that up with a question from myself, if you don't mind.
Sure.
I know some of my colleagues, they actually contributed themselves to the EU directives that you mentioned. So it's a two-part question. Firstly, did AEGIS and/or yourself contribute to the EU directives at all? As I know many people that did. And what do you see as the plan for future compliance work as we diverge from EU standards? So will we stay mostly in alignment? You presumably sell a lot of your plant and your services to the EU anyway, and therefore you'll have to keep in line with EU standards, or do you see a significant divergence?
Well, the first part of the question, we weren't involved in the drafting. AEGIS certification is actually a relatively new company. Although AEGIS engineering is 25 years old, AEGIS certification has been around since 2018. So we are starting to become involved in the drafting of standards, but historically we've not been that involved. We sit on NOBO forums and plant assessment body forums, etc. In terms of Divergence from Europe, I don't know, to be honest. I'm sure that on January the 1st, things will be exactly the same as they are, simply because to diverge requires work to create some new processes and some new standards, and people need time to undertake that work. And quite frankly, on the list of things that need to be organised for us to leave the EU, railway standards probably fairly low down the list. In terms of divergence in the future, I think there is potential for us to diverge fairly heavily, because we actually already do technically diverge quite a lot. In terms of machines being sold into the UK, mainly because of our gauge, every single machine that's sold into the UK is UK specific. And anyone from the UK that sells into mainland Europe would often make a mainland Europe version because our gauge is so onerous. So actually, our approvals business has always been, and probably always will be, focused on UK approvals, because if you're selling into the UK, you would use a UK approvals body who, know the local processes. So I suppose in summary, I don't know how much we diverge, but I think there is the potential to diverge quite heavily. Certainly in plant, rail industry standards are quite a lot more onerous than the Euro norms already.
Cool, thank you very much. So next question comes from, second one from Michael James. This is, road rail machines are a comparatively new technology, and in the early days, some manufacturers were naive in their understanding of CE marking. Would you agree that there has been a step change in the understanding of RRV manufacturers to today's railway?
Yes, without a doubt. I think generally there's been a step change in the machines themselves. Network Rail ran what they called an RRV safety improvement program about 5 years ago now, that included things like fitting brakes to rail wheels, which sounds crazy, but that's when they first started being fitted. So there has, in the last few years, been a step change, I think, in plant design. And then specifically with regards to CE marking, issue 6 of the rail industry standard came out about 2 years ago, and that had a new clause which said you must CE mark your machine and you must use this harmonized standard as your presumption of conformity. And I think that's the first time that the requirement for CE marking was A, understood at all, and B, taken seriously. I think prior to that, well, I know prior to that, a lot of RRVs weren't CE marked, which seems incredible because they are machines and they fall under the Machinery Directive, but people were not aware of that. But now to get past essentially the second stage of the process, which is the engineering acceptance, you need to have done your CE marking. And then, as I discussed in the presentation, to work on Network Rail, not only do you need to have done it, but someone's going to come along and scrutinize it and check that you understood what you were doing when you did it. So I think, yes, that there has been a huge change in the understanding of CE marking and manufacturers' accountability for it. I think previously they assumed that the person doing the third-party certification held technical accountability for the machine, and really they've realized recently that as a manufacturer they hold a very large accountability for the machine and the safety.
Cool, thank you. Okay, next question comes from Steve Smith. It is, who are the competitors to AEGIS, and what makes you different?
The competitors are other railway consultancies who I'm sure you can go out and find if you want to. What makes us different? is, I think, two things we pride ourselves on are our technical thoroughness. We really do, we care that the machines comply with the standards, and we will, that's not to say that the others don't, but we certainly pride ourselves on putting a high level of depth into our scrutiny. But we're also reactive to customers' needs, and plant in particular is a high-paced, high-volume industry, and a lot of the work being done to plants is being done by owners and operators as well as manufacturers, and we really try to understand their needs in terms of what they're trying to achieve and when they need to achieve it by, and react as fast as possible and meet those needs. I think the plant industry, or the rail plant industry, is the volumes are just on a scale that's not really comparable to things like rolling stock, where they're very high value, relatively low volume. We sometimes receive an inquiry on a Monday and we could be certifying a machine on a Friday, and that's really where we try to stand out from the rest, is that ability to react to customers' needs.
Oh, thank you. I'm going to come in with another question for myself, if you don't mind this time. Do you do any follow-ups for checking issued certificates? So you mentioned about the maintenance review that you do. So after a year or two after entry into service, do you go back and check the plant is performing as you certified it would do, or is this check only done by the owner or the hirer?
It's only done by the owner or the hirer. Technically, our responsibility ends once we issue the certificate. However, as part of our technical competence, we obviously monitor railway incidents through NIRs, RAID reports, Network Rail, safety bulletins, things like that. And we do have an obligation to, where we become aware of a non-conformance at a later date, we do have an obligation to rescind that certificate. So although we are not obliged to go out checking machines, we are obliged to monitor the industry in general, and we are obliged to act on any information we receive. And we have had instances where machines that we've certified have been involved in incidents. That excavator lying on its side is an obvious example that I was involved in. As soon as I become aware of that, I have an obligation to find out what happened. And if there was some sort of technical non-compliance, then we would have an obligation as a company to rescind that certificate.
Okay, thank you. Interestingly, the next question, you've partially answered it already. I'm going to ask it anyway, just to see if you want to expand on your answer. Comes from Steve Clark. So it's, can the process be reversed and products be decertified down the line for a particular reason? Obviously, you've just answered essentially that is yes, but he continued with, how would that be undertaken and would it involve yourselves?
So it would involve ourselves. It can be undertaken in a number of ways. The most formal way is that if we become aware of an issue with a machine, we can go to the person, essentially our client at the time, and say, we're aware of a non-compliance with this machine. You need to provide us with some evidence that you've rectified it, or we're going to rescind your certificate. Or we may not rescind it, we may place an additional limitation on that certificate. So where we thought there was some, the brakes weren't good enough to operate on a 1 in 25 gradient, we may put on the certificate that it can only be used on lesser gradients. I've never been involved in that process of actually rescinding a certificate. or even changing a certificate. The other way it could happen, and actually is probably the more likely way it would happen, is that Network Rail have a do not use list, which they publish every Friday. Now, if you can imagine some of these machines, you may have a fleet of machines that was certified 14 years ago, scattered among a number of owners. If a issue arises with a particular machine, it's actually applicable to all of those machines, and digging out the certificates, which may have been issued by different PABs in the days before thorough computer records were kept, could actually be more difficult than just putting them on the do not use list. So if there is an issue, the issue will always be managed with Network Rail, with them being such a big stakeholder in all of this. And the most effective way to have a machine not be used on a Saturday night is to put it on the do not use list. But yes, we can essentially undertake the compliance review that we undertook the first time round with some greater level of depth. So we may undertake some further specific testing on the machine to further evaluate the compliance of it.
Ooh, right, thank you very much. I'm going to go back to another question of mine. Now, I've run out of questions. There was a follow-up from Jamie Walsh, but he said you've just answered his follow-up point anyway. I've had a few. Thank you, Sam. Excellent presentation from, again, Jamie. A great presentation from Andy McIntosh. And Steve Clark also said, thank you for the presentation, very informative. That's all the questions I've got from the audience. I've got 2 questions of my own lined up, which I will ask you now, but if anyone else has any more questions, feel free to stick them in the chat while I do these 2, and if not, then we'll wrap up after these 2. So you mentioned separate entities about between the engineering sides and the certification side. Do they need to be legally separate entities, carrying the same branding, but completely legally separate companies, or is it just sort of wholly owned subsidiaries, the administratively separate companies? And what bearing does that have in terms of if there was a court case, or if anything did end up in worst case killing someone or something like that?
They're separate companies, part of the same group of companies, so they'll generally be owned by a single holding company. We have an annual audit from UCAS, who accredit us as a certification body, and a large part of their audit is always impartiality, and necessarily a large part of their audit is how we maintain impartiality between our 2 companies. So it's accepted that they would be owned by the same holding group, and that's how all of the other certification bodies operate. But UCAS put a lot of scrutiny into the management systems in place and the roles and responsibilities of individuals to ensure that people at my level doing the certification work are not influenced by the commercial objectives of the consultancy company, essentially.
Thank you. And my second question, if I'm just going to carry on with my own. So you mentioned that as part of the process, you check for the stated performance, such as can it do a certain amount of tamping in a certain period of time. Where do these expectations come from? Is it just the manufacturer declares it can do a tamping rate of something, or do you work with project teams to say, yeah, I need a tamper to be able to do a certain amount, and this tamper claims it can? Is it literally just whatever the manufacturer publishes, or is it something wider than that?
It depends who's buying the machine. If Network Rail are buying the machine, then it comes from their procurement specification. So when they go out to buy a machine, they'll say, we need a machine that can do X, Y, and Z, in which case that will be the performance. If it's not being bought by Network Rail, then yes, it's whatever the manufacturer declares it is. So it's essentially what they're advertising in their brochure as the performance of the machine.
Right, thank you very much. That concludes all the questions. I have no further questions for you, Sam. There's no more in the chat. No one's asked to speak directly, and I haven't got anything for myself. So I will draw to a close there. Jeremy, if I can ask you to unmute yourself, I will pass over to Jeremy for a vote of thanks. Thank you very much.
Okay, Sam, thank you for launching the Thames Valley section into the online meeting world. We really appreciate all the time and effort you've put in to complete this demanding task. It must be very daunting for you at your end because you've got no faces to look at. At least we're looking at you. You're speaking to a screen full of initials and names, and it's very difficult to judge how the audience is taking it when you can't see how it's happening. So very difficult on your end. So thank you for that. You've covered a very complex system of approvals with a very detailed set of slides. All I can say is thank goodness I don't have to deal with first of class and second of class, because I'd be ending up with the second of class in the wrong space and first of class. It's a really good job that AEGIS are there to guide people through this process, because it frightens me to death looking at that. I thought, God, I'm glad I don't have to get anything on track, because that would be a real nightmare. You're obviously a total expert in your field. You've clearly shown this in your presentation this evening, so thank you for that. And it just leaves me to say, on behalf of Thames Valley section, thank you very much for a very detailed explanation of a very complex subject. Obviously, we'll give you a round of applause, but all you're going to get is a virtual set of applause from me, and I'm sure everyone else will be doing the same from their end. So thank you very much indeed. And Phil, thank you for hosting it.
If everyone wants to unmute their microphones, everyone does have the ability to unmute themselves. So if we could all unmute our microphones briefly and give a genuine round of applause over GoToMeeting, I think that would be quite appropriate at this moment.
Thank you very much.
Oh dear, what happened? Okay, Phil, over to you. You need to unmute.
Yep, sorry. There we go. Right, that concludes proceedings for the evening. Thank you very much. I shall stop recording now.